Hi, welcome to Dissolve Chemistry. Let us continue our discussion on this equilibrium. In the previous video of equilibrium, we have discussed various equilibrium established in physical process, particularly in phase transitions such as solid liquid, liquid vapor and solid vapor we have discussed. So let us continue with the equilibrium established in physical process with the new equilibrium, that is the equilibrium involving dissolution of one, we will take solid in liquids, and second one we will take it as gas in liquids. Okay, so now suppose you are dissolving solid in liquid, that results into what? Solution. Okay, so let us see what is solution. Solute plus solvent, we call it as what? Solution. Okay, here solute we are taking solid and your solvent is liquid. Okay, so resulting will be called as solution. So let us define what is this solute. First we will see what is solution. A homogeneous mixture of, I will show you the experiment, homogeneous mixture of, okay, homogeneous mixture of two or more components, we call it as what? Solution. And in that, which is in small quantity referred as solute, which is in large quantity referred as solvent. Okay, then next important point, you should know what is a saturated solution to understand equilibrium established between solid and liquid during dissolution. Okay, so that is saturated solution. Okay, I will show you with experiment how the saturated solutions are prepared. Now what you do yourself. Okay, I will also show you and you try to do that one. You take a 100 ml of water and then you start adding sugar to that. What happens? 1 spoon you add and okay, so it will dissolve and you will get a homogeneous mixture. That is solution, you will get clear solution. Then what you do? You add another spoon of sugar. Okay, so then you dissolve it. It will dissolve and you will get a clear solution. You go on adding and stirring it. So then you will be getting clear solution, and at certain point what happens? There is no further dissolution of the sugar you are going to observe. Okay, so let us see that experiment and you try to understand what is saturated solution, because that is very important to understand this particular equilibrium. Okay, here I have taken 100 ml of water. Okay, so to that I am adding, see, 1 spoon of sugar I have added. Okay, so now you see here, so crystals are what? So they are settling at the bottom, and if I stir this one, okay, so then what happens? So it starts dissolving. See, now you got with an homogeneous mixture of sugar and water, and this we call it as what? Solution. Okay, so now what we will do? We will add another spoon of sugar. Okay, 2-3 spoons we will add together and we will try to dissolve it. Okay. So look at here, the maximum amount of the sugar has been dissolved in the water. Now the additional amount what I have been added to this, now it is depositing at the bottom, because further there is no dissolution, means it has reached a saturation point. Okay, solution has reached a saturation point, meaning is what? No further dissolution of the sugar we are going to observe. In such situation, what happens? Now what happens? A dynamic equilibrium is established between the sugar crystals which are in the solid state and the sugar which is already dissolved in the liquid phase. And that equilibrium we call it as what? Equilibrium involving dissolution of solid in liquid phase. Okay, so now what happens, suppose if you go for if you heat, it happens at room temperature. Now we are doing this experiment. Now if I keep it on the flame, then what happens, it will start dissolving, means further still more it is going to dissolve. And if you cool it, then what happens, recrystallization will occur. And after that what happens, a dynamic equilibrium is being established between the sugar crystals in the solid state and sugar already dissolved in the liquid phase. Okay, you can clearly observe this one. So the sugar is depositing at the bottom because already it has reached the saturation point. Put this one. Okay, we will write the things. What we did, we took 100 ml of water and we have added sugar to this, and after reaching a saturation point, so the sugar is depositing, solid sugar is depositing at the bottom, and already sugar is present in the solution phase. Sugar, okay, in solution and sugar in the solid state. Okay, so now what happens, so some of the sugar molecules will enter into the solution phase and some of the sugar molecules from the solution phase will start depositing over the or starts recrystallizing, okay, and depositing in the solid phase. So how we will represent sugar, or you can call it as solid sugar in liquid phase, okay, or in solution you can call, and sugar in solid state. So now there is an dynamic equilibrium is being established between these two, okay, and that we call it as what, an equilibrium between solid upon dissolution in liquid. Okay, beyond that point at a given temperature you cannot dissolve further what, solute into the solution. Okay, but it doesn't mean that a rate of dissolution, okay, so rate of dissolution and rate of crystallization, now what happens, becomes equal. This we call it as rate of crystallization and rate of dissolution, now both becomes equal. So therefore what happens, it establishes a dynamic equilibrium. Okay, next we will talk about this gas in liquids. Probably you might have come across with any team, if it wins the match, then they celebrate in the dressing room as by what, opening the bottle of champagne and fizzing out. What happens, the gas will fizz out and they are going to celebrate. Okay, so like in that what you will observe is when you open the champagne bottle, so what happens, what gas will fizz out. What is the reason behind that? So that is what we are going to discuss, the equilibrium which is being established in dissolving gas in liquid phase. Here gas is solute and liquid is solvent. Now suppose if you take a gas in a closed vessel, okay, in a liquid, over the surface of that gas is, okay, added to this, then what happens, gas is going to dissolve, okay, into the liquid phase, and the amount of gas dissolved depends upon how much pressure we are applying on that. Okay, so now what happens, the gas molecule will enter into the liquid phase and some of the molecules will start getting out of that, okay, or escaping into the gaseous phase. Now the number of molecules dissolved into the liquid phase, that depends upon what, how much pressure you are applying on this gas, and that is being said by Henry's law. Okay, so that we will define later. Let us understand this one. So now as the gas is packed in a closed vessel where the liquid phase is present, so therefore what happens, the gas will start dissolving in it. Okay, so how much amount of the gas is being dissolved, that depends, already I have said, depends upon the pressure, how much you have applied, or with what pressure gas is being packed over the surface of the liquid. So now after certain interval of time, you are not applying the, you have made the pressure also constant and you kept it aside, okay, and you are maintaining the temperature also constant. Then what happens, some of the molecules which are dissolved in the liquid phase will start getting into the gaseous phase, and some of the molecules in the gaseous phase get into the liquid phase. Okay, and as the rate of number of molecules getting into the gas phase, number of molecules getting into the liquid phase, so if it becomes equal, so then what happens, we call it as what, a dynamic equilibrium is established between gas, and gas in liquid phase, gas in gaseous phase, gas in liquid phase. Okay, so that a dynamic equilibrium we are going to observe. Now what we can do is we can shift the equilibrium towards dissolution of gas into the liquid phase, means maximum amount of the gas we can dissolve in liquid by applying the pressure, and that is being said by Henry's law. Okay, and what Henry's law says, see here, amount of gas dissolved in a known weight of liquid is directly proportional to the pressure applied on the gas over the surface of liquid. Okay, so that is what we call it as what, Henry's law. It is called as Henry's law. Okay, so amount of gas dissolved in a known weight of a liquid is directly proportional to the pressure of the gas, pressure applied on the gas over the surface of the liquid at constant temperature. That also we have to mention. Okay, we have to maintain the constant temperature. Okay, usually it is more amount of the gas can be dissolved at lower temperature. You should remember that. Okay, so therefore in all these soft drinks, okay, or carbonated drinks, what we call, in that carbon dioxide gas is being dissolved, okay, in water under high pressure. Because of that reason only, when you open the bottle, what happens, it fizzes out, okay, or bubbles will come out, and that is because of escaping of the gas, because it is forcibly it is being added to the water under pressure. Okay, so when you open up, the gas will come out of it, right? So that is what we call it as what, equilibrium between the gaseous phase and gas in a liquid phase. I hope you have understood the concept and what is Henry's law. Make note of this. This is very important exam point of view. You should remember that. Okay, so now what we will do, so we will generalize, okay, or we draw the conclusion, right? So conclusion what we can draw is, the first one is the equilibrium between solid and liquid phase. Okay, it occurs at atmospheric pressure at a particular temperature, we call. At atmospheric pressure, the equilibrium between solid and liquid is established at a particular temperature. And that particular temperature we call it as what? What is that? It is known as melting point, where both solid and liquid are going to coexist if heat is not absorbed at that particular temperature. Okay, that is what conclusion we can draw for that. Second one is the equilibrium between liquid and vapor phase. So it is at a given constant temperature. At a given temperature, vapor pressure, okay, at a given temperature, vapor pressure of pure liquid, okay, remains constant. And third important point is for dissolution of solid in liquid, the solubility is constant at a given temperature. Okay, and last point is, okay, for a dissolution of gas, in liquid, okay, the solubility depends upon the pressure applied, constant temperature. Okay, so these are the conclusions we can draw for the equilibrium established in the physical process. That is, always remember the equilibrium between solid and liquid occurs only at a particular temperature at atmospheric pressure, and always remember at a given temperature vapor pressure of the pure liquid remains always constant at a given temperature, and the solubility, okay, so for dissolution of solid in liquid, so where solubility is constant at a given temperature. Okay, so if you want to enhance its solubility, you have to raise the temperature, right? So similarly, if you want to enhance the solubility of gas in liquid, you have to apply the pressure. More and more pressure if you apply at a given temperature, more amount of the gas we can dissolve in liquid phase. Okay, and we can shift the equilibrium towards dissolution of gas into the liquid phase. Okay, I hope you have understood. So in the next video we will discuss regarding various aspects of the chemical equilibrium. Okay, so this completes the equilibrium in physical process. Okay, if you have any doubts, please write in the comment box. Okay, thank you for watching.